We'll look at how the answers for this were found, how the x and y intercepts were found for each of these two different functions, the vertical asymptotes and the horizontal asymptote, and trying to show where those answers came from. So I'm going to start with the first one, y equals x plus 4 over x plus 2. Excuse me. So we have this rational function here. And we've got a polynomial in the numerator, polynomial in the denominator, x plus 4 and x plus 2. They're both first degree polynomials or linear polynomials. If we want to find the y-intercept of any polynomial, we want to keep y as it is and set x to 0. Because if you remember, the y-intercept is always going to be right on the x equals 0 point. I just did a terrible job of explaining that. But the y-intercept, since it crosses the y-axis at some point, x will always be 0 where that y-axis is. All right, so we set x to be 0. Well, 0 plus 4 is 4. 0 plus 2 is 2. That wasn't so bad. And 4 divided by 2 is 2. So y is 2 when x is 0. Found the y-intercept. That wasn't so bad for that one. The x-intercept, same idea. The x-intercept, the graph is going to cross the x-intercept or x-axis at some point, and y will be 0. So we set y to be 0. And really, there's two ways to do this problem. One way is to think about it as something divided by something equals 0. Well, the only way that's going to happen is if the numerator is 0. 0 divided by anything is going to be 0. So let's double check that there's no issues with that. Let's plug in 0. Let's see. What would make this 0? Excuse me. If I want 0 divided by something to be 0, well, negative 4 plus 4 is 0. So negative 4 plus 4, that'd be 0. If I plug that into the denominator, I get, well, again, negative 4 plus 4 is 0. That's what I wanted. Negative 4 plus 2 is negative 2. You can do 0 divided by anything you want. I get 0. So x would have to be negative 4. So you can do a little bit of guess and check. You could look at the problem and decide what would make the numerator 0, and just double check that you don't end up with 0 divided by 0. That would be an issue. Otherwise, you're pretty much good to go. So x would be negative 4 in this case, and our x-intercept would be negative 4, 0. The other way that you could solve it, and I'll do that maybe up here, is if we had 0 equals x plus 4 over x plus 2, that should be enough room. If I wanted to solve this for x, I could multiply by whatever's in the denominator here. If it's divided by x plus 2, I can do times x plus 2. X plus 2 divided by x plus 2 is 1. Multiply the other side by x plus 2. Well, 0 times anything is 0. And then I could solve for x from there and see that x equals negative 4. And so you could solve for x by using algebraic reasoning. You could also look at the problem and say, well, I know 0 divided by anything is going to be 0. So what would make the numerator 0? Well, negative 4 plus 4 would be 0. So that works. Either way, you get the same answer. The x-intercept, negative 4, 0. Okay, so that was a little offshoot there. Okay, we found the y-intercept, found the x-intercept. Now let's find the asymptotes. So if we want to find the vertical asymptote, the vertical asymptote is essentially the exception. It's where it's the one value in the domain, one or more values, I guess, in the domain that lead to a problem. Really what we're looking at is what can you not divide by? You can't divide by 0. So what would make the denominator 0? Kind of like what we did for the x-intercept. We're asking, we can't let the denominator equal 0. It's an issue. And so we want to know what would make x plus 2 is the denominator. What would make x plus 2 equal to 0? Well, if x was negative 2, we'd have a problem, because then negative 2 plus 2 would be 0. Black holes, issues, no good. And so that would be our vertical asymptote. Vertical asymptote is always written as an equation, x equals something, and that gives us a vertical line on the graph. The horizontal asymptote, will be a y equals something. That's going to be our going across asymptote, zero slope for that. And we had two rules that were in the notes. One of the rules said if the numerator is the same as the denominator, the degree, I should say, if the degree of the numerator is the same as the degree in the denominator, this is a first degree polynomial, this is a first degree polynomial, then the horizontal asymptote is going to be whatever the first coefficient, or the coefficient here is, the leading coefficient, 1, over the leading coefficient for this one, 1. So 1 and 1, the horizontal asymptote is going to equal 1 over 1. Well, 1 divided by 1 is just 1. So the horizontal asymptote in this case would be 1. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote would be y equals 0, which is the x-axis. And that's how we get the answer for that one.